Welcome to the Storage Essentials Sales Training, part of the Collaboration Essentials series. Over the next 10 or so minutes, I want to give you a novel perspective on the storage management market. I'll be your host. My name is Doug Clower, the Global Enablement Manager for End User Computing. Let's start by reviewing a few terms you may want to be prepared to explain and discuss with customers. There are two definitions of SaaS that are used today. The most common is software as a service, which refers to cloud-based software. In context with file and storage management, there's an emergence of the term storage as a service, but regardless, it's still classified as a SaaS capability. Good examples of this are for-fee services like SugarSync, Dropbox, Box.net, and similar type online storage solutions. Other more enterprise scalable storage offerings exist, such as Amazon's Simple Storage Service, or Amazon S3, and Amazon's Elastic Block Service, and both are part of Amazon's Web Service, AWS. Of course, other good examples of non-storage software as a service include Google Apps, 37 Signals, and Salesforce.com. Infrastructure as a service is the delivery of computer infrastructure, typically a platform virtualization environment, as a service. The original term, hardware as a service, was first coined by economist Nicholas Carr, but the key characteristics of IaaS include resource delivered as a service, dynamic scalability, variable cost service, multi-tenancy, and enterprise-grade infrastructure. Some good examples of vendors providing IaaS are Amazon's EC2, SkyTap, and Rackspace. Platform as a service is the delivery of a computing platform and solution stack as a service. It often goes further with the provisioning of a software development platform that is designed for cloud computing at the top of the cloud stack. Some vendors in this space include Aptana Cloud, Salesforce.com, Azure Service Platform, Google Apps, Open Platform as a Service, WorkExpress, and Rackspace Cloud. Now let's turn our attention to capacities, specifically storage capacities. Some of you may remember that at one time computers stored data on a single-sided, single-density 8-inch floppy disk that would barely store 80 kilobits of information. Today we think of files in the megabytes or even maybe gigabytes in size, but when thinking about mass storage platforms, the capacities are much higher. Terabyte drives are common, and clusters of these drives are aggregated in hardware platforms to provide hundreds to thousands of terabytes, also known as a petabyte, of networked storage services. Now, these terms may be unfamiliar to you, so to put in context, as I said, a petabyte is 1,000 terabytes, and an exabyte is 1,000 petabytes, and a zettabyte is 1,000 exabytes. The short of it is that a zettabyte is a billion terabytes, so these are quite significant amounts of data. According to IDC, the amount of stored information will grow to nearly 1.8 zettabytes. That's 1,800 exabytes by 2011. To provide a little more context, as of 2004, Google had an estimated 5.625 petabytes of hard drive space in their server farm. In what might be more tangible illustration or something more real, if you collected all the printed material in the world today, that would consist of an estimated 200 petabytes. So as of 2004, even Google didn't have enough capacity to store it all. Now, let's turn our attention to the storage management market. This market is divided into two categories: hardware and software. The hardware vendors provide the storage platforms or bare metal bit storage devices used within these storage environments, and they provide low-level software to help provision space within that hardware. The capabilities of the software these hardware vendors provide vary substantially, with some providing feature-rich tool sets, while others can be quite basic. These shortcomings leave a gap for a non-hardware vendor to fill. These software vendors deliver a variety of storage solutions that overlap with hardware vendors, but also provide backup, disaster recovery, deduplication, global management, and reporting. Another advantage specialized software vendors provide is cross-platform functionality, meaning that their solution runs across all hardware vendor platforms. Now, let's quickly cover some data management models. There's information lifecycle management, which is a comprehensive business approach to managing the flow of an information system data and associated metadata from creation and initial storage to the time when it becomes obsolete and is deleted. Unlike earlier approaches to data storage management, ILM involves all aspects of dealing with data, starting from user practices rather than just automating storage procedures. For example, hierarchical storage management does this. And in contrast to older systems, ILM enables more complex criteria for storage management than data age and frequency of access. There are generally 5 phases that data traverses in the ILM model. That's creation and receipt, distribution, use, maintenance, and disposition. A technical implementation of ILM is data lifecycle management, a policy-based approach to managing the flow of data throughout its lifecycle, from creation and initial storage to the time when it becomes obsolete and is deleted. As a rule, newer data and data that must be accessed more frequently is stored on faster, more expensive storage media, while less critical data is stored on cheaper but slower devices. Now, storage resource management is another way of approaching the management of the storage environment, and it sort of fits in the model space, but it doesn't quite. As a general rule, though, SRM software is targeted to accomplish the following set of tasks: SAN design and analysis, LUN management and provisioning, capacity management and planning, disk health monitoring, backup management, block level tiering and disaster recovery, root cause analysis, capacity management and planning, quota management, chargeback, SAN path management, device discovery and reporting, hardware change management and alerts, storage array and fabric configuration management, file system inventory and reporting. Hardware and software vendors deliver on these capabilities in varying degrees, each with merits that favor different aspects of the file system management lifecycle. Now let's look at a high-level architecture of storage management. All storage begins with the hardware, whether it's mainframe-based direct access storage devices or just a bunch of disks. This is generally defined as block storage, focusing on the bits on the disk. Today, there are 3 mutually coexistent methods for connecting block storage to computing platforms: direct attached storage, network attached storage, and storage area networks. Each has a management interface to provision raw space into logical volumes, or LUNs. Once a physical device presents raw unformatted space to a computing platform, it must be carved into logical volumes of the appropriate type that server can utilize. Each provides management capabilities delivered through the operating system driver and software. Each operating system now provisions, formats, and aggregates this space to be consumed by different applications. At this point, the storage no longer exists at just the block layer, but is presented in the file record layer, referred to as file space. File space is the amount of space available to store any type of file in the file system. When a file is created in the file system, a sufficient amount of physical file space is allocated to contain the file. These files are categorized by how they're organized and managed. They're described as structured data and unstructured data. Structured data is information held in the file system where there is a data model that describes how the information is represented and managed. Unstructured data refers to the files stored in the file system that are typically associated with an individual or role rather than a data model. Storage resource management, whether provided by a hardware vendor or a specialized software vendor, seeks to manage the storage resources across the complete storage paradigm. Unstructured data management needs to incorporate identity as a factor in addressing this need. The system that stores, organizes, and provides access to information about any given object, regardless of its type, is referred to as directory services. Objects can include, among other things, computers, printers, software applications, roles, and identities. SRM software is beneficial in configuring and monitoring a storage infrastructure, but falls short in the areas of automated file-based tiering and particularly management of data based on policy driven by identity and role. Organizations need a solution to address higher-level data management needs with more intelligence. Novell File Management Suite is an integrated offering that provisions, moves, optimizes, and reports on file storage based on user roles and customized business policies. Simply put, Novell File Management Suite empowers customers to intelligently manage their file storage for maximum business benefit. Thank you very much for taking the time to watch this Storage Essentials sales training. This has been Doug Clower with Novell, your host, wishing you happy selling.